To start off, not only hardware, it's certainly also about software.
Indeed, yeah.
But indeed, the topic of my presentation is automated damage inspection, to which I will refer to as ADI. I'm with Camco Technology, managing the software project department. Camco is already active for many years. Already done over 300 projects. Important to know is we have local service centers all over the world to serve our customers. And what is in this presentation certainly important is that from the start we do a lot of our design and production, both for hard and software, on our own, and we invest a lot of our revenue back into innovation. So what do? We automate on the gate end image-based solutions, location-based solutions with OCR portals, self-service systems, vehicle booking systems, and so on. We do the same at the rail side. We also automate through portals, camera portals, but also on the RMG cranes, we install camera systems. And again, also through position detection system, which we label under RTLS, real-time location systems. One of the more recent developments for our cranes is also the possibility to install cameras on the cranes. I'm mentioning all this because image-based automation, of course, the ADI or the automated damage inspection can run on all those solutions. We also automate the yard with the same technologies, and also on the cranes. We also provide image-based solutions as well as location-based solutions. Now, before I go into more detail on ADI, automated damage inspection, also mention we have two main software platforms. There is our platform, The Bridge, which brings everything together, allows you to have a very comprehensive access to all your automation solutions on your terminal. And if you want to even specialize further, there is also our digital twin solution, which allows you to monitor, replay, and simulate different transactions on your terminal. When we talk about AI, then for Camco, that means that we go a long way back. Actually, from the start of when we were founded in 1999, to be more specific, in 2000, we already implemented AI solutions. Because that's actually one of the core parts of our products. And back in the day, that was not yet with neural networks or let alone generative AI. That was more with basic solutions which were more common back then. Feature extraction, edge detection, image segmentation. And why did we use that? Well, in the beginning, we installed camera portals, and it allows us to find back the images. We made high resolution images from the start, but you also needed a way to trace them back besides just a timestamp. And that's why back in the day, we already started with implementing license plate, container ID recognition. Over the years, we expanded the features that were supported. And for example, in 2010, we also added wagon number recognition, so rail wagon number recognition, and also ADR label detection, the dangerous good labels. Still with the same, you see we come from a long way. Still after 10 years, it was still with the classic approach, but we have to say it was back in the day and actually still can be very reliable as well. And then at some point in 2016, we started moving towards newer technologies, but not yet with neural networks, but moving towards that direction. Because then we re-implemented our ADR label recognition. And that's also typical that neural networks for like feature detection, they're much more strong. So that was also the reason why for the dangerous good labels, which is mainly an image being displayed, that we introduced it first for this one. And then our first neural network based implementation was again then for license plate. And then we come on the next milestone. That was in 2020. We did our first proof of concept for ADI. It was for container ADI, so container automatic damage inspection. And yeah, of course, this was neural network based. There would not be another way to implement this. So that was the start for us, that we also were introducing neural networks into our system. Evolving then to 2023, all of our OCR products were migrated to neural networks. And now we are even moving forward again, and then it's on the hardware side. Our cameras, they do have GPU acceleration, but not yet like NVIDIA based. So now it's even more powerful cameras that we're introducing, allowing us to go even further in doing more difficult detections, but also more performant systems. Now, when we look at ADI, automatic damage inspection, how do we approach it? And this is something that has already, in the other presentation, been mentioned. That the important thing is you need samples, of course. So that's an important aspect of the training of our ADI models. We need to collect picture sets with damages, and the source for that is our own systems. That's also important that it's our own systems, because that renders the best results. And that's a human direction, a human task still. And the second thing is also then categorizing and labeling. That's what they call the labeling process, those different types of damages, so that we can, as a next step, train an ADI model. So that renders then, after the labeling, we put it in our training software, and what comes out is ADI models, as we call them, and they are then divided per type of damage, sometimes also the location of the damage. So we have different ADI models, which we then can deploy on our cameras that are in the field. That's also important to know. All our recognition software, not only the OCR, but also the automatic damage inspection models, they run on the cameras, which make sure that you do not need special hardware on the server side. That's something that we take care of. And what is also important to know is that we train those models for all our solutions. So it's not that we need to train specifically for gate, rail, or crane. No, we can use the same models, so they contain samples of all different solutions, and they are used all for those different solutions. So how does it work then in practice? Well, we run our ADI models on the camera. When there is a container or a trailer that passes, besides the OCR engines, the ADI engine will do its work. It will do the recognitions, process everything, and it will render a list of, well, either no damage or a list with damage and damage properties. And our system then, that could be our gate system, that could also be our rail system or our crane system. It will process those damages and decide whether there is an operator intervention needed or not. This is typically, and that's also decided together with the customer, but I will come to that. This is typically for major damage, but we still consider it as a supportive tool, as an assisted tool. So in case of detection of damage, the normal setup would be that there is an operator involved to confirm the damage is real and is correctly detected. Now, once that step has been done or not done, depending on the type of damage, the TOS, the information of the damage, will be sent to TOS in its own format. And once again, from the TOS side, the damage could be consulted as well, but more in a data form than rather than in a visual form, which on our end, through our archiving system, you can also look up the pictures of any passage and also consult what damage is being detected. The way it looks, you can see here. So on the left side, you can see the detected damages. Of course, this is a very obvious picture with a lot of damage. In reality, it's not always that obvious, and that's also the challenge, of course, with this type of detection system. On the right side, you can see the images then, and you can see what where the damage was located and whether all damage, if needed. You could also verify whether the damage is real or if there is damage being that needs to be added. Now, what is important is that's something that we learned very early, is that you need to have a proper definition of damage. The customer on one side have often different requirements. We notice some customers, they have a very basic definition of damage, going from major, minor damage. But we have also other customers that go to very detailed definition of damage, especially also with regards to the location where the damage is located. You have the CDEX coding system, for example. The challenge here was that for Camco, our ADI models need to be maintainable. We cannot, like for every customer specific requirement, train our ADI models, because then we would have hundreds of ADI models. So it was quite quickly that we decided we need to define a proper ADI model that covers our needs now, but also for future extensions and future capabilities. And how do we come then to the customer's definition of the damage? Well, that is through mapping. So there would be a mapping step in between the detection done by Camco to the customer's definition. When we look at the container damage definition, well, there are 4 properties that are in our definition with all different types that are there. We have, first of all, the damage type property, and you can have different damage types like deformation, hole, tape, open. Open can be for a door, can also be for a hinge. Yeah, tape is very specific because we do not know what's underneath the tape, so that also needs to be detected. The second property there is component. Here is a container being shown, but it can be for any, can be for other cargo types as well. The component is then the part of the container, in this case, where the damage would be located. The third property would be location, and it's always, location is always oriented based on the object. So in this case, the container, so the back location will always be the door side. It will be same for trailer. And then the fourth one is the severity. So how severe is a certain damage? And of course, this, yeah, there is a certain definition here, but that's also why there is a mapping that allows us to adjust it to whatever the customer considers severe or not. If you bring then all those 4 properties together, like you can see here in this slide, that gives, of course, a lot of possible combinations, and there lies this challenge, specifically with container or ADI, automatic damage inspection. There are a lot of possibilities if you combine all those different properties. But now, how do we work now with our ADI model? So we have the output of the damage type, component, location, and severity. We then map it, and that's literally a mapping table, and that's where our customers can decide how they want to map it to their own definition. And it go like here, it's a very simple example. On the left side, you see the Camco definition of damage. On the right side, you see major damage, yes or no, and TOS damage ID, for example. But it can be much more elaborated. There can be much more properties to which we translate the damage. And then typically, like I said, normally it would be a supervised setup. Sorry, from major damage, there will be an ADI operator review, and after which it's being sent to an external system, typically the TOS, internal operating system. For minor damage, typically it's logged, but it's not like reviewed by an operator, so it's sent to the TOS, but not reviewed. That would be the typical setup of an ADI system. Now we come to the real challenge, and that's something that is very often not shown. Also, I think sometimes not in the presentations today. Yeah, how do you measure performance? Sorry, Camco in the beginning had a background with OCR systems, optical character recognition systems, and there, yeah, doing performance measurement is quite easy. You can do accuracy evaluation by just taking a population. Typically it's 500 consecutive results, and there are only maybe 5, maximum 10 properties that you are recognizing, like it could be a license plate, container ID, and so on. But with and then you would just measure, you would just review those cases, and whether it's right or wrong, you would have a hit rate. You can even make other assumptions on true positives, true negatives, and so on. But with the container ADI or ADI in general, it's much more complicated. When you look at the mapping table that I've shown before, you have over 100 combined features, which would mean that you would need to do 100 manual reviews, which is not feasible, but that's not the only thing. In most cases where we supply our solutions at terminals, the number of real damages is not that high, and so the number of true negatives, so the ones where would be no damage detected, that is the largest share. So also there, collecting sufficient big population to have some kind of a true positive share is it's actually impossible. So what we do for now is we focus on evaluating based on the operator review whether the true what are the true positives and what are the false positives, and that's then what we would call precision statistically. But that's a topic that is certainly not yet closed. That's an ongoing part of properly measuring the performance of such an ADI system, or in general AI system. When we look at our installed base, for Gate, we have already 29 sites which have or will soon be operational with ADI in place, 18 of them being operational already. For Rail, that's also the most recent one, the last one to which we have added ADI. There are 4 sites, of which one is already operational. And for Crane, we have 14 sites with 6 operational. Now, to close off the presentations, what are our next steps? Well, we are expanding the library of ADI models that we have, and one of those is tank ADI. So at this moment, that's not part yet of our library. So we're now training to detect structural damage, frame and corner cast deformation, hole detection, open lid detection, which is typical for tank cargo. We're also training on additional components on the existing models: door handle and bar deformation, tarpaulin presence, reefer damage check, and then something that will remain continuous effort is that we need to collect samples, like I mentioned. We need to train, we need to retrain, we need to enforce the model. And that's a continuous effort. We have a dedicated team for that effort, and that's what we continue to do. That was my presentation. I thank you for your